Chemistry happens everywhere, not just in flasks in laboratories. Chemical reactions happen when plants make food during photosynthesis, when animals, including us humans, eat the food and digest it, and then use the carbon, hydrogen, oxygen and nitrogen to build cells, tissues and organs. Every step in these processes is a chemical reaction. Bikes rust in the rain, petrol burns to move our cars, food decomposes and acids and bases combine to neutralize each other. All of this is chemistry. A study of chemistry will open your eyes to every aspect of life. Life has changed incredibly in the last 200 years, more than at any time before in history. The Earth's population is 5 times greater and life expectancy has more than doubled. Chemical research has contributed to this by developing an enormous range of products, from medicines which have extended human life and reduced suffering, to fertilizers and agrochemicals, without which the Earth could not possibly feed its 7 billion inhabitants. The number of deaths from heart disease and stroke alone has halved, treated by medicines produced here in Ireland. 9 of the world's top 10 pharmaceutical companies have substantial operations in Ireland, with 24,500 people directly employed in the sector and another 24,000 indirectly employed in support services. Ireland is the 8th largest producer of pharmaceuticals in the world. That all amounts to a lot of job opportunities. Studying chemistry for the Leaving Cert is a very useful foundation for a career in many different sectors. Chemistry directly links with careers in pharmacy, engineering, medicine, veterinary science, nutrition, etc. But there are also lots of associated careers in areas such as compliance, marketing, public relations and sales. If you've enjoyed Junior Cert Science, especially the practicals, and have done well in science and honours maths in the Junior Cert, then you should be a good candidate for Leaving Cert Chemistry. Higher level chemistry is for students who are both practical and also able to cope with abstract ideas, scientifically minded and curious about how our world works. The advantages of doing well in higher level chemistry are a really good grounding in an area of science which is a link and basis for so many other areas. You will have a greater understanding of other science subjects, and it will be a big advantage if your third level course has chemistry content. Ordinary level chemistry is for students who are technically minded and practical but not necessarily planning to do chemistry at third level. It is a good subject to have for careers in food, welding, plumbing and heating, or working as an electrician. All in all, chemistry will give you a great introduction into what an amazing world we live in. You will understand much more about how everything works and how interconnected all parts of our lives are. You will not just learn theory, but do lots of practical work. Learn how to take careful measurements, organise practicals, troubleshoot, interpret, present results, and work in a team to complete the task. These are all valuable skills in any area of life. Think back to when you learned about the Bohr diagram of the atom and the periodic table. If you are able to make sense of these topics easily, then you will be fine with Leaving Cert Chemistry. Don't worry about needing honours maths. The mathematical content of the course requires just a good grasp of ordinary level Leaving Cert maths. So what will you learn in Leaving Cert Chemistry? The course begins with some history. You already know from the Junior Cert that the periodic table is an organised table of all elements which exist on our planet, a list of ingredients for the Earth if you like, and that all the elements on the periodic table are made of 3 types of particles: protons, neutrons and electrons. You will now learn how scientists work this out, how the elements were discovered, and how by breaking them down they found these particles. It really is amazing to contemplate that every single thing on Earth, including ourselves, is composed from elements listed on the periodic table. Like all living things, we humans are mainly made from oxygen, carbon and hydrogen. Leaving Cert Chemistry is essential to have a good basis for food science and nutrition studies. It is very important that nutritionists know the chemistry of food and, of course, people, because we truly are what we eat. Have a look at this table. These are the elements that make up a human being. Of course, our food is also made of these elements. Carbohydrates and fats are carbon, hydrogen and oxygen, and proteins are also carbon, hydrogen, oxygen with some nitrogen. Our food is not just to give us energy. We eat and break down the food, and then our bodies use the components to build and repair our cells, tissues and organs. Food also provides the small bits of other elements we need, like calcium, phosphorus, iron, etc., to complete the job. You will study chemical bonding in detail. Of course, all matter on Earth is made from the elements either in pure form or bonded together to make compounds, like hydrogen and oxygen combined to make water. The work of an industrial chemist is to expand on the range of natural substances and get elements to combine which would not naturally happen, and so produce things like medicines, plastics, dyes, synthetic fabrics, etc. You will have learnt ionic and covalent bonding in Junior Cert, and you will now learn more about this at Leaving Cert. You will also learn about the bonds from one molecule to the next, intermolecular bonds, and what effect this has on substances. Does this matter to anything, you may ask? Look at the water molecule and the carbon dioxide molecule. Did you ever wonder why water is liquid and carbon dioxide is gas? Possibly this may never have crossed your mind, but given that liquid water makes up the oceans and rivers and covers 70% of the world, and even humans are approximately 2/3 water, try to imagine the consequences of water being a gas. Would life on Earth be the same? Would there even be life on Earth? Intermolecular bonds explain this. Ever heard of Kevlar? It is a fabric which is really useful due to its very strong intermolecular bonds. It is used to make things like bulletproof vests, canoes and sails, all of which need to be lightweight but very tough. Kevlar is just made from carbon, hydrogen, oxygen and nitrogen, no metals. It is very lightweight but is still stronger than steel due to the strong intermolecular bonds from one Kevlar molecule to another. Shape of molecules is also studied for Leaving Cert. Shape is also important in the study of enzymes and catalysts. For an enzyme to work, it must be the right shape to fit into the particular place in the cell wall. This is true also for many medicines. The shape of the molecule must be right to block or to activate sites on cell walls. Another area which you will study in chemistry is how it is possible to speed up, slow down or change the direction of a chemical reaction. Chemical engineers are concerned with this type of problem. For instance, we study the production of ammonia in the fertilizer industry. We also study catalysts. These are substances which speed up or slow down reactions. We learn how different types work and uses for them, like the catalytic converter in a car exhaust, which is coated with metals like platinum and which causes polluting chemicals to react together, essentially knocking each other out and producing less harmful emissions into the atmosphere. A large section of the course is organic chemistry, the chemistry of substances based on carbon. Carbon can form rings and chains, and this gives rise to millions of carbon-based substances. Many of these substances are found in living things, and as we already mentioned, these are made of carbon combined with hydrogen and oxygen. Even though there are millions of compounds, they can be studied in different families with similar characteristics, and this simplifies things quite a bit. We start with hydrocarbon fuels. You will learn about the components of crude oil, how they are separated and what they are used for. Oil is such an important part of modern life, not just for petrol and diesel, but did you know that paints, dyes, synthetic fabrics and plastics and lots more products come from the chemical processing of oil? It's true to say that chemists of the future will have to develop different ways to produce all these products from different sources or from recycling as oil becomes scarce. An example of a practical you will do is converting ethanol from the alcohol family to ethene from the alkene family. Ethanol is the active ingredient in beer and wine, and ethene is the gas produced by ripening bananas, two very different substances. In the lab, you convert ethanol to ethene by removing a water molecule using a catalyst. If you add chlorine to the ethene, you get dry cleaning solvent. If, on the other hand, you link lots of ethene molecules using high pressure, you get plastic, polyethylene. So from ethanol to banana gas to dry cleaning solvent or to a plastic, this is chemistry. Other carbon-based substances have been extracted from living things or used to make medicines. Ancient man chewed willow bark for pain relief, and in the 19th century, chemists found the active ingredient in the bark. This was called salicylate or salicylic acid. It was tweaked and aspirin is the result. Aspirin has given rise to a huge range of similar anti-inflammatory drugs. More recently, venom from a South American snake was used as the basis of a medicine to lower blood pressure, and yew trees provided a substance called Taxol, which has been developed into a cancer treatment. Chemists have worked out a structure of the substances and can copy them in the lab, so they no longer have to catch the snakes or chop down the trees. From an environmental point of view, the section of the course on water and water analysis is very relevant. How is clean drinking water produced, and how is sewage treated to make it harmless? You will learn how much we rely on bacteria to do the dirty work for us in the sewage treatment. You will also learn to test water for oxygen content and hardness and learn how to detect heavy metals like lead or arsenic. Without good materials, manufacturing, engineering and building construction would be limited. Without effective medicines, doctors would be quite powerless. Without fertilizers and crop protection, farmers would not feed the world. Chemistry has provided the materials and the medicines to sustain our lives. But there is still so much to do to protect our environment and to ensure that life on Earth continues to improve for everyone. Studying chemistry could be your first step to be part of this.